Let's understand the working of ceiling fan. First of all, let's disassemble the fan. In this fan there is a single-phase induction motor. This is a stator of fan, and as its name, this part is stationary. This is a rotor ring, and this part is contact with fan outer casing, so when this part is rotate, the fan is rotate. On this stator core, there are two windings, starting winding, and running winding. Windings are wound on stator core, and for prevent earthing, insulated paper is used. The stator core is made up of stampings, to reduce the eddy current effect, and hysteresis losses. Induction motor is not self-starting but why? When we give the alternative current to the winding, it produces magnetic field, which is continuously changing from north to south, and south to north. When this alternative magnetic field cut the rotor ring, according to Faraday law, an EMF is induced in rotor ring, and current is flow in ring. When a current-carrying conductor is placed in a magnetic field, a mechanical force is exerted on the conductor, which can make the conductor move, but in this case the whole ring is rotate, rather than move. We know that alternating current change its direction in every half cycle. In positive cycle of alternating current, the torque produced on a ring is clockwise, and in negative cycle, anti-clockwise. This change in cycle is very rapid, 100 times in 1 second if frequency is 50 Hz. It is not possible for ring to change its direction quickly due to its inertia. Hence the resultant torque is zero, and the ring is not rotate. So, to overcome this problem, for give starting torque to our fan, we use second winding or starting winding, and a capacitor. The capacitor is put in series with starting winding. This whole arrangement is in parallel with running winding. How this arrangement work? Let's see. There are two waveforms of current in starting winding and running winding. The capacitor is in series with starting winding, so the current in starting winding is lead by 90 degree. We know that the magnetic field or flux is directly proportional to the current, so the magnetic field of starting winding is also lead by 90 degree. At 0 degree, the current in running winding is 0, but current in starting winding is maximum. So the resultant magnetic field is at a 0 degree. At 45 degree, the current in running winding is average, and current in starting winding is average. So the resultant magnetic field is at a 45 degree. At 90 degree, the current in running winding is maximum, but current in starting winding is 0. So the resultant magnetic field is at a